In this presentation, we'll be showing you our final design for the iMechie Repeatable Vehicle Challenge. We've modified our design in a number of ways, taking into account the feedback given to us by experts at the end of week 1, in addition to the new regulations which place a greater emphasis on speed and efficiency. We began by modifying our wheels. We were told by the experts that 3D printed wheels would not have enough traction. Instead, we'll be using rubber wheels, which will be mounted precisely using 3D printed axles with slots for bearings to allow for frictionless movement.
Please compare the motor on the left. You can see that the new motor is perfect for our purposes. Perfect speed, perfect torque. In addition, this saves space because we don't need to reduce the gears as much for our distance mechanism.
For our chassis, in order to reduce weight, we decided to 3D print axle holders and axles. This reduced the weight by 80 grams, comparison to our previous aluminium parts. The whole assembly is fitted together using M3 and M10 and nut and bolts. And the wooden base plate area was reduced by 82 centimeters squared, which saved around 15 grams of mass.
The names in the bill of materials cross-reference those in the CAD model parts. It includes materials, density, manufacturer details, and VAT in the bill of materials. You can see that total cost amounts to £21.16, which is under our current budget of £30. You can see that total mass is 0.714 kilograms, which is lightweight as possible, saving us energy.
We made a spreadsheet with correct equations in each column so that we can check our values by entering different parameters, which is our load of calculation when comparing with the simulation. From the spreadsheet, we got maximum speed 0.294 meters per second and total energy 3.59 joules. Using the spreadsheet, we are able to get a rough estimate of total energy. Our hand calculations include work done by the wheel, the losses due to the air resistance and rolling resistance. Hand calculation for total time of the run is 12.37 seconds, and it is taken from the spreadsheet. The part marked in red in the spreadsheet is the time for the vehicle to decelerate, which the detail will be shown in the next slide.
For the deceleration calculations, our mass had changed, so certain variables had changed. We then solved the ODE like last time and got a max deceleration of around 0.3 G. This had gone down from 0.4 G, and this was due to the mass going down of our vehicle.
When running our simulation, we obtained the following performance curves as shown here. Our new maximum velocity is now 0.253 meters per second with a maximum simulated deceleration of 0.35 G. These results closely match the values that we obtained from our hand calculations in the ODE. Our energy usage plot is shown here. The time taken for the run is now around 13 seconds compared to 34 seconds for our old model, and this was achieved with a faster top speed. Our new mass was half that of our previous model, leading to a much lower energy usage of 1.64 joules. We can say that our simulation results were conclusive because they roughly match our hand calculations.